now we know that we can talk about energy conservation for a particular system. What's important is to choose the correct system in order to do the problem and actually to make it easier. Choosing the right system is going to be very important. So first we have to realize that only forces due to agents outside of a system, and we can define the system ourselves any way we want, are able to do work, i.e. transfer energy within the system. The equation that you end up writing depends on the choice of the system. So what we're going to do is I'm going to show you 3 example systems which are actually all related, and the only difference will be where the bounding box that we choose for the system is. So the first system we're going to look at is a weight that's being suspended under tension from a chain, and of course the weight itself is in a gravitational field, so it has some weight pulling down on it. And let's assume that the tension is enough to accelerate the object upward with an acceleration a. If we draw our first system boundary such that it's right around the weight, then we know that both of the forces, both the tension and the weight, are due to the environment, and thus they are external forces that are able to do work. In this case, the change in the kinetic energy is equal to the work that's done. For the second system, again, it's a bigger system. If we can step back, and now we also encompass the Earth in our system, we can see now the Earth is part of our system. That means that the force due to gravity, due to the Earth, is also internal into the system. That means that only the tension is an external force causing that acceleration, whereas the weight is now an internal force. And that means that our equation for our energy conservation will change. Now we have the change in kinetic energy plus the change in the gravitational potential energy is equal to the work that's being done on the weight. Finally, we can zoom even farther out on this system and include the crane that's actually causing the acceleration, and because it's what's connected to the other end of this chain that's pulling the weight up. Now all of the forces are internal and the system is completely isolated. There are many forces, internal forces inside the chain, inside the crane, including chemical forces that are causing the motor to rotate, the axles that are causing the weight to be lifted up. And when we do this, now this is an even more complicated expression, which is that the change in the kinetic energy plus the change in the potential energy due to gravity plus the change in the chemical energy, all of that must be conserved, and that's all equal to 0. So this is equal to 0 now because everything is inside and there's no other forces acting from the outside, of the system. So that means that the total energy of the entire system must be conserved.